All right, since I know everyone's ready, let's see. So, class.
Yes.
Thank you. All right. So everyone is going to be participating today, and if you're not, you at least pretending like you're participating, I would approve of that. So we're going to go through, and we're going to use the information that we had previously as we went through the notes to try and solve the rest of this. Now for 5, if I were to open up my notes, and I have one of these, an inscribed polygon, it says something specific about opposite angles. So if you're scrolling through your notes, find the picture in your notes. Find the picture in your notes with this here. So open your notes. I know you can't hear me because you got earbuds in for some reason, but you know, come on now. So open your notes. If it's an open notes test, you might want to actually have your notes open so you know where things are, right? You know your notebook is still closed, right? Yes, thank you. Thank you. Okay, find the one that looks like this with the inscribed polygon. Find in my notes. It is an inscribed polygon. So, if you're following along, it is over on page 15. On page 15, it is there. So it's on the back side of our notes on page 15. What's it say about this inscribed polygon? What you got? It says opposite angles are supplementary. Okay? Now, there's a reason why I'm having you find this in your notes, because can you use these notes on the test? Yes. So if by you knowing where it's at right now in your notebook, that should be beneficial. Right? Okay. So opposite angles are supplementary. So that means that together they have to add up to 180. So D is opposite of this 110. So if they together have to add up to 180, because that's what supplementary is, I would do 180 minus 110, which is going to give me? 70. So D is 70. Now, this one over here, it also gave me, looking for this one on the outside. We'll find that one in a second. But this side on the inside over here, on the inside right here, this one is opposite my 140. So if that one's opposite 140, I would do 180 minus 140, which is going to give me 40. And that's the one on the inside. Okay? So this is where you're actually looking. We're using a lot of the process that we've already gone through. So, what type of line is that right there? That line that I just drew. That's 180. That's a straight line, isn't it? So if that's a straight line, it has to add up to 180. If this piece over here, we said, was 40, right? That means this one on the outside has to be its supplementary. So if that's 40 over here, what's this on the outside? 140. So this on the outside for angle E is 140. So we're going around using the information that we have in our notes to find not just the one I'm looking for directly. Sometimes I need to find something else, so it's an indirect. So I find one thing which is going to help me find the next. All right, so now on this one, out here on the outside is 124. And again, this right here is a straight line. This straight line is 180. So to find the one for angle B, I would do 180 minus 124. I heard an answer. 56. Yes? Okay, good. So angle B is 56. This shape is inscribed, and B and C are opposite each other. So that means that B and C together have to add up to 180. So they're supplementary. So what is going to be supplementary to 56? 124. Find the value of the marked angle. Okay, you ready? This one goes with the radius that we talked about before. Now, before we get too far into this, let's identify this. This is going to be necessary. What type of line is that? I heard it? Not 180. It's a special type of line. Mine's pretty good. Tangent. My tan, right? Okay. See what I was going for that? My tan. Okay, almost. I tried. Anyway, so pointed tangent. So the tangent touches the circle at a single point. And where it touches the circle, it creates what with the radius? It's almost like I might want to find that in my notes somewhere if I cannot answer that currently. So scroll through your notes, find something with a tangent line. Huh? We're dealing with the tangent line, right? Okay. Okay, but okay, so there's one, but that one's not it though. So a point of tangency. Where can we find the point of tangency? Okay, how about 7? It is on 17, but that has to do with solving for other types of problems. On page 7, it tells me specifically the definition to go along with it. 6. Right, here it is. So on page 7, at the point of tangency, what does that create? It creates a right angle. Very good. So for those people following, right there where it touches is going to create a right angle. So I know that this right here has to be 90 degrees. Yes? Okay, this is important right now. So if that's 90 degrees from there to there, didn't they give me a little sliver right here that says that that is 38? It's 38, isn't it? But together, both of them together have to add up to 90. They are complementary to each other. So if they both together add up to 90, what's my missing piece? 52?
Yeah.
Yeah, because 90 minus 38 should give me 52. So this piece, using all that information right there, is going to tell me that this over here is 52 degrees. Now we could either go back to the notes that we did yesterday, or we can go back to our identities about triangles. Or not, I'm sorry, not triangles, circles. What do we know about the radius of the circle?
It's the same.
They're all the same, right? Okay, so the special rules in a triangle, if the two legs are the same, it makes a special type of triangle. Anyone recall that word? Isosceles, very good. It is an isosceles triangle. So my legs are the same, and so also are my feet. So my base angles are also going to be the same. So we said that this one over here is 52. So can you guess what A is going to be? 52, because in an isosceles triangle, the legs are the same and the feet are the same. So angle A is going to be 52 degrees. Now, we also know a rule about triangles. All triangles have to add up to what? I heard it? 180. All angles in a triangle will always add up to 180, right? So if they all add up to 180, I have 52, 52, and some missing value. What can I do to find the missing value? Subtract it, right? Subtract it from 180, or add the two 52s, and then subtract from 180. So either way, so I'm going to write it out like this. So I'm going to say 180 minus 52 minus 52. All right, so after I did that, I said that's 104, and 180 minus 104 is going to give me 76. Very good. So angle B is 76 degrees. Now, this one looks kind of crazy, but I'm pretty sure I have one just like this in my notes somewhere, right? Okay, I'm almost positive I do. But guess what? I know I do because I wrote the notes. Okay, in this question, write down the reason for your answers and find all these things. So, again, let's go back to my circles. From O, B, and OC. Both of those are, what's the word? They are congruent. They're both radius, or both radii, and they're both congruent. So that goes back to, if this right here is an isosceles triangle, if the legs are congruent, so are the feet, right?
Yeah.
So this piece right here is 25. Guess what this one over here is?
25.
25. So if I label this correctly, it would be OCB. OCB, or if I write it the other way, BCO. That's neither one of these, but okay, that's going to be necessary for here in a minute. So we have that. That is 25 also. Okay, so now let's look right here. This thing right here looks like a tangent, and it's touching right there. Do we have a question in my notes that looked almost exactly like that?
No,
Yes.
I'm joking.
Yes, you do.
I cannot find it.
You cannot find one that looks exactly like that?
Yeah.
Okay, this one's actually referring to angles now. Okay,
It's on page 7?
page 9? Let me see, page 9.
No, it's page 7. Yeah. Oh, no, it's on the 7.
Some of it. Does 7 have some more of it on there? 7, yes, we do have side links, but we're not dealing with side links right now. We're talking about angles, right? So there's a link to the side, so it's not going to be 7.
2.
Arc minus
17.
arc. What's the sign? Where's the one that says arc minus arc? Are you missing something?
Me?
Someone help me out. Where's it at where it says the two arcs? Where we're finding the arcs. Inside and outside. Nope. It would have been 11 then. It's the notes. One. Okay, so I'll just pull up the notes. Trying to call me a liar. How dare you?
Let's find out.
Okay, so let's see. Bam.
No, what's the same? I see you, Mr.
You said what? You still weren't right.
No. Yeah,
It's not page 7.
page 7.
If it would have been.
You could say all you want, but it's still not right. Angle relationship. So where's this one at? Where's this one at?
That's 7.
That's 17?
Is that one?
Yeah. It should be on 17.
It should be on 17. That one should be 17.
Yeah. Angle relationship.
Yeah.
Yeah.
Theorem 1153. It's page 17. Okay, so my apologies. It is 17. Okay, I'm trying to look through people's notes that are missing stuff. Oh, that's why yours is empty. I can't find any notebook because you're missing those pages. Ah. What's wrong with this one?
Just one paper.
And that's the one I was looking for. Anyway, all right, so we're going to look at this, and we're going to look at our different arcs, and we're going to try and find our angles given that information. All right. Okay. So, again, we have a triangle. I'm going to use this triangle right here.
180.
Yes, that's supposed to be 180, right?
That's 130.
One what?
130.
120,
And 130.
130.
Yeah.
Angle O right here is 130. How'd you get 130?
No, 140. I add up 25 from 25.
Which is?
Subtract it with 180. Give me the 130.
130.
So it's 130, right? Because I subtracted my 25 twice. So right here at BOC is going to be 130. So my angle right here, 130. Okay, so now, let's see if you guys are paying attention now. So we said that one's 130. Let's see if you got this now. I'm pretty sure you do.
It's the same, mister.
So from B to C,
Oh, it's around.
from B to C, what's going to be that arc? Why is it 130? That's called, anyone recall what it's called? Good job, central angle. So my central angle is 130, and that's going to be the same as my arc. So my arc over here is going to be 130. Okay. So 130 is my arc. So my, let me see. BC arc is 130, and we're going to use that one here in a moment. Because I'm eventually going to need to get CAB. So we got that right there. That one's 130. Now, that's from there to there. But before we go too far, because in my formula, I need to have this one too. Because I'm going to my formula here, and my formula, it's going to look like this, isn't it? Because it's going to be like item 2. We have a point here to point here. So angle 2, which is going to be over here, is going to be EHG, which is going to be my outside, minus my inside, E to G, and then 1/2. And that's going to give me that angle way out here. So according to my notes, I'm going to say that I have my 1/2, because I'm trying to get this one out here. That's going to be CAB. My outside angle, if my arc was 130, this whole circle, what does the circle add up to?
23. Is that
23?
No, I know, but
Okay, I can't trust you with this.
half of that.
You keep using tape for everything.
No,
You're
I
wasting
know,
my
but
tape.
I
Stop
was
it.
thinking that half
Malo. Okay,
it's 220.
now, together they have to add up to 360, right? 360. So I'm going to do 360 minus 130, which is going to give me 230. 230. So my big arc is 230 minus my little arc, which is, so after I do my math, 230 minus 130, does that say 100? 100. What's half of 100? 50. So over here is going to be and let's see the next one. So where are we at? And this next one is BDC. So B to D to C. Okay. Now let's see if you guys paid attention on that last problem. B to D to C. We're looking for this angle right here. But before you yell out anything, look at this shape right here. What is that? It's black?
No,
What did he say?
it's the same. It's the same.
It's not the same. Is that a is this a polygon? Okay. So let's see what we have here. Since we have a polygon over here, okay, we're gonna have to try and find some other values.
Can't you use it as an inscribed angle as well?
And all 4 sides would have to be inscribed though. That's a good point there. So I can't call it an inscribed, can I? Because all 4 would have to be inscribed. Where we only have 3 inscribed, the 4th one is not.
No, I meant this part. Oops, sorry. This part right here, wouldn't this be inscribed? Oh, I just accidentally.
No, it's fine, don't worry about it. No, it is kinda, but that's not where the, cause right there, to be an inscribed, this is just an inscribed triangle. Okay, but we're trying to do the whole thing right here, cause I don't have this piece here, this piece here. I have those, and I have that, but I can identify it as a full polygon, but it's not inscribed polygon.
Gotcha.
So, because of that, I'm gonna have to actually try and figure out some other stuff to go along with that. Since I got that's gonna be 30, let's look over here. This is going to be an inscribed of all of this here.
Yeah, that's what I was talking about.
Oh, is it? Oh, I'm sorry. I thought you were still trying to like talk about inscribe. My bad. I'm stupid. No, I'm stupid. I didn't understand what you're saying. Yeah, yes. So I was still thinking polygon, but it's not. Okay. So yes, I'm kind of stupid. Anyway, so we said that the arc out here was going to be 230, and I really don't like that color. The arc is 230, and the inscribed angle to go along with it is going to be half. What's half of 230? I heard it? 115. There you go. There we go. So, now we're using a whole lot of the same stuff over and over again. We have inscribed arcs, we have inscribed angles, we have triangles, we have straight lines, all the stuff that's are actually currently in your notes but not in yours, okay, we're using. Okay, question 9 here.
That's different.
I almost heard what you said.
It's like this.
It's like these? Oh, you don't have this one? You have a different one?
Yeah.
No, we have that one, but it's just on a different page.
Oh, it's on a different page? Is that what it is?
Oh, you have a big thing.
Okay, yeah, so on mine it got messed up. So yeah, go to number 10.
Oh, is it?
Yes.
Madonna?
Yeah. God, wait, who's gone? That creature's gone. I don't think he's ever come back. Okay, so if he shows back up in a couple minutes, if he doesn't show back up, I'll write you a pass, and I'll call the police looking for missing persons. Okay, so let's do it. For you people again on your notes, this is number 10, isn't it?
Yeah.
There you go. All right, so we're gonna have a lot of information here. So this is a radius, here to here, right? That one is going to be 6 centimeters. But O to B is also 6 centimeters because the legs are congruent in this triangle. All right, so this over here is 50 degrees. What's my arc going to be? 50. It's the same. There's going to be 50 degrees. Now, let's look. Same endpoints. This is what type of angle there? Inscribed. Very good. So if it's inscribed as touching the edges, okay, so we know that the inscribed angle is what? Half. So half the arc. So my arc is 50. My inscribed is 25. All right, so let's go through and actually find some more stuff to go along with this. So, angle ACB, ACB, okay, this one's going to be 25. Find the size of angle OAB, OAB. Okay, so OAB is going to be from here to here. So we had a problem like this earlier. There's my isosceles triangle. The blue triangle right there is isosceles. If the legs are the same, then so are the feet, right?
Yeah.
So if this is 50 right here,
Yeah.
I know that all triangles add up to 180, so I'm going to go 180 minus 50 is 130, right? So both the feet together add up to 130. So to figure out each foot, since they're going to be equal, I would take that number and divide by 2. Very good. So let's take that and divide by 2. So 130 divided by 2, which is going to give me 65. So my angle right there is going to be 65. So does it mean it's the same for over here?
Yeah.
Yes, it is. The radius of the circle is 6 centimeters. Okay, so calculate the length of the minor arc ABC. Okay, so now we're going to length. We just did the angles. Okay, so where am I at now? I am
The length of AB,
AB,
arc AB.
arc AB. Okay, minor arc AB, we said that is 50. Did I say it right? A to B, yes, 50. Calculate the area of the minor sector OAB.
Quick question.
Yes,
The arc length, isn't it 2 pi r times your measurement over 360?
angle divided by 360 times,
2 pi r, right? Circumference times angle over 360?
for area is pi r squared.
Yeah, for area it's pi r squared.
Yeah, pi r squared, so.
So wouldn't it be 2 pi r for the first one?
Wait,
Instead of 50?
I-
You put 50 degrees, not the length. So wouldn't that be 2 pi r times the measurement?
the minor arc. Oh, you're right. Okay, so yes. Dang, you know what? I should just right here. I'm not having a good day. All right, that's it. I give up. Okay, I have been vested. So we said 50. Thank you. Times 2 pi r. And my r in this case was supposed to be 6. Thank you for catching me on that. Yeah. So, man, I would have taught. I hate making mistakes. I really do. Because I didn't read it all the way. R6. So, there's my arc length, and then we'll do the area after that.
Yeah, it's 6. Because your radius is 6, right?
You're doing a good job, mister.
I know. No, I'm not. I'm not having a good day. I made a mistake on my earlier stuff too, and I'm still just like slapping myself for it. I should have just stayed in bed today. All right. Did anyone actually put this in their calculator that hopefully everyone's using?
That's 6.
Yes, it is. It's just a very bad 6. And the calculator you're allowed to use is your NumWorks calculator. 5.23. So, anyone else? Anyone else? Agree? Disagree?
Can I do it this round?
Huh? 5.2 would work, or 5.23 still good. So, I'm hoping you guys actually are trying. Other people are not trying. They're just staring awkwardly, waiting for someone to give them the answers.
Are you rounding to 2 decimal places?
We can do 1 or 2, doesn't really matter.
5.24.
Yeah.
5.24?
Yeah. 5.4.
5.24?
Yeah, it go up because instead of 5.35.
So you round up because
Yeah.
it's a 5. Yeah.
See, like I said, that's why I need people here to check my work, because I suck at math.
What's the number behind it? So it depends on what it's asking for. So if it's asking you to round to 2 decimal places, you're gonna round to that one.
Yeah.
doesn't
Yeah, it doesn't say, so we're just putting it there. And if you would have put just 5.2, guess what? It's still correct. So, now the area of the sector. OAB. OAB. There we go. Area of the sector. It's a slice of pizza. Yes, it's a slice of pizza, right? Yes, it's a very ugly looking pizza. It's very small. It's only 6 centimeters, so it's like a tiny pizza. You ready? So that's going to be theta over 360 times pi r squared. And in this case, my theta, which is my central angle, is going to be 50 over 360 pi. My radius is 6, close and square.
What time is the square?
The square, you're looking for the square on the calculator, is what you're saying?
Yeah, no. I said that time is square too.
50 over 360 pi times
15.7.
15.7,
Yeah.
or if I was rounding it to another one, it would be 15.71.
Oh yeah.
It would, right? Okay. So 15.7. Where's my notes? And that's centimeters squared. All right. And guess what? So, I canceled out a whole bunch of these problems, so you guys don't have to actually do them all. You're going to use the rest of this time today, work on getting any of those things, any of those pages that you didn't have done, or you're doing the corrections for the problems that you did get wrong. You're going to work on that.
I do.
We're going to do the test tomorrow in class, and I'm going to manipulate it so we only have 10 questions of these. Okay, the practice usually has some more because I do multiple of each type of problem, but I'm going to limit this one down to 10.
Thank you.
There we go. And if you're missing pages, you go get them right now. Make sure you all like, share, and subscribe.
Where is